Financial algebra, we are going to go over 10.1. And a lot of 10.1, a lot of the formulas we're going to use are formulas we used in prior lessons a long time ago. So for example, we're going to be utilizing the periodic deposit investment amount, and that was from lesson 2.7. So we've got our balance equals our periodic deposit, R is our rate, N is how often we compound it, and T is for time. And then we're also going to be using our present value formula. That was from lesson 2.8, and it's where we find the value of how much we would need to deposit today. So we're going to do some examples of each. So number 1, Ethan is 48 years old. He's planning on retiring when he's 62. He opens an IRA with, here's our rate, compounded monthly. He makes monthly deposits of $850. How much will he have in the account when he's ready to retire? Well, if he wants to retire when he's 62 and he's 48 now, we needed to determine the number of years. So if I subtract that, I get 14 years. So that's T. My rate is 0.0295. My deposits are $850. And compounded monthly is my N value, and there are, I guess I don't need to circle this, there are 12 months in a year. So we're going to plug this into our formula right here. It's not asking how much we have today or what we need to deposit today. It's asking how much we're going to have. So we're going to use this first formula. So our balance equals our monthly deposits are P times, in parentheses, 1 plus our rate divided by N. To the, I have 14 times 12 minus 1. And then all over my rate times N. All right, so I'm going to start with the bottom first. And so using my calculator, I'm going to divide, and I get, you want as many decimals as possible to keep it accurate. And then now I'm going to enter the top. So grabbing my calculator, it's a lot to enter, 850 times, so parentheses, and then I'm going to do another parentheses because that's what this bracket is. So 1 plus 0.0295 divided by 12, parentheses, and then my exponent button, parentheses, 14 times 12, parentheses, minus 1, parentheses. And so I get 433.99. Now I'm going to divide the top divided by the bottom, and I get $176,538.33. So this is how much would be in his account if he made monthly deposits of $850 for the next 14 years. It's a lot of money. This same one is almost identical. Number 2 is almost identical, so I'm going to go ahead and skip it and move on to number 3. All right, so if Jillian started a retirement account with $10,000 when she turned 35, the account compounds interest. So wait, first 10,000, interest quarterly. Here's our rate. She made no further deposits. After 20 years, she decided to withdraw 40% in the account so she could make her home handicap accessible, and she had to pay a 10% penalty. So first of all, let's figure out how much is in her account. Now, she did not make periodic, so a one-time deposit would look like this. Whoops. If you only make a deposit once, it's P times 1 plus R over N to the N times T. So this is a one-time deposit formula. And she only made one deposit at the very beginning. Okay, so here we go. What's in our account if you deposit $10,000? 1 plus our rate of, 0.3625 divided by, it's quarterly, and then in 20 years, so 20 times quarterly. Quarterly, there are 4 quarters in the year. So again, we can enter this all at once. So 10,000, parentheses, 1 plus our rate, 0.03625 divided by 4, parentheses, exponent button, 20 times 4 is 80. So she has $20,579.99. Did I do something wrong? Hold on. Sorry, I think I did something wrong. Nope, okay. So I'm going to round this to 2580. All right, so first things first, it says she withdraws 40%. So what's 40% of what's in her account? I multiply by 0.40. So 0.40 times 2850, and I get 8340. And then of that, she pays a 10% penalty, so times 0.10, she's going to pay $834 penalty. So if you withdraw money early from your account, you have to pay a penalty. All right, we're going to move on to number 4. So Tanya is 42 years old. She would like to open a retirement account so that she will have $500,000. $500,000 is $500,000 when she retires at 65. So again, we have to figure out in how many years is that. So 65 minus 42, that is 23 years. So T equals 23. How much must she deposit each month? So that's where we need to know her present value, what she needs to deposit now with an APR of 2.75 compounded monthly. So since we're looking for the present value or what we need to deposit now, we're using this formula here. So how much must I deposit now? If I want $500,000 times my rate divided by N, monthly means 12, divided by, and then it's our standard formula for interest. So 1 plus our rate divided by 12 to the 12 times 23 minus 1. All right, so I'm going to enter the top first. So $500,000, parentheses, our rate divided by 12, and I get 11.45 and 83 cents, and that 83 cents is repeating. Now I'm going to enter the bottom. So parentheses 1 plus our rate divided by 12 to the, and in parentheses I'm going to put 12 times 23 parentheses, and then out here minus 1. And I get 0.88095. So if I divide those two, I get $1,300. Wait, let me make sure. 1145.83 divided by 0.88095. $1,300.68. So about $13.01 if you round to the nearest dollar. All right, moving on to number 5. John is 59 and a half. He plans to retire in 3 years. He now has $600,000 in a savings account that yields, so he's got this much money. Here's his interest, compounded continuously. So I'm going to write that equation here. This is for compounded continuously. He has calculated that his final working year salary will be $115,000, and he's been told by his advisor that he should have between 60 and 70% of his final year annual income available to use. So what is the range of his income? Well, I need to figure out what's 60% of $115,000 and what's 70% of $115,000. So I'm going to enter those two amounts. 60% equals $69,000. 70% equals $80,500. So his range is $69,000 to $80,500. Use the continually compoundous formula to determine how much he will have in his account at the beginning of retirement. So here's our formula. So A equals 600,000 is what's in his account right now, times E to his interest rate, so 0.034 times 3 years. So all you have to do is enter it, 600,000 times, you have to hit the shift button, E, 0.034 times, and he says retire in 3 years. So in 3 years, he will have $664,430.08. If he uses 60% of his annual salary, how many years will this money last? So 664,430. I'm just going to round, divided by 60% of his income, so 69,000. How many years does that give him? So 664,430 divided by 69,000. It will last him about 9.5 years. Moving on. All right, so moving on to number 6. Melanie has been contributing to a retirement account that pays 3.875 interest pre-tax. So something to know about pre-tax dollars is pre-tax reduces your taxable income because you're investing it somewhere before it makes it to you. The account compounds interest monthly. She's put $300 per month into an account. At the end of 8 years, she needed money for a down payment. She took out 25% of the money. So the first thing we need to do is determine what's in her account and then what's 25% of that. So part A is going to be a little long. I have to use that formula. So the balance equals, she's been making monthly payments of $300 times 1 plus her rate divided by monthly to it's in 8 years, so 8 times 12. Whoops. Minus 1 divided by her rate divided by 12. All right, so the bottom, I get 0.003229. And for the top, I get 108.823. So if I divide, I have that she has $33,701.86. So it says that she withdrew 25%. So what is 25% of the amount that's in her account? $33,701.86. So I'm going to enter that, 0.25 times $33,701.86. Rounded to the nearest dollar, she withdrew $84.25. Because she's in the 21st tax bracket, what was her tax liability on the amount she withdrew? So 21% of the amount she withdrew. If you multiply that, I get her tax liability is $1,769.25. She has to now pay 10% penalty for withdrawing early. So what's 10% of the amount she withdrew of $84.25? That's $842.50. So how much did this withdrawal cost her? You have to add the two together. So here's her tax liability plus her 10% penalty. This cost her, hold on, let me add it. This cost her $2,611.75 to make an early withdrawal. That's a lot. All right. Number 7, and there is a table that they have provided us with to find tax liability in your book. So make sure you utilize that while you're doing this. All right, so Meryl contributed $500 pre-tax dollars per month into her retirement. Her taxable income was $77,480. She files as married, filing separate. What would her taxable income have been if she had contributed after tax? So if she had contributed after tax, you would actually add. And so she did $500 per month. So 500 times 12 is $6,000. So this amount plus $6,000 is $83,480. Find her tax liability. So $83,480 would be between here. Married filing separate is here. So that's $14,324. This is after tax. If she had only done $77,480, $12,973 is pre. So how much did she save? You would subtract. So $14,324 minus $12,973, and she saved $1,360. Now I have a couple more. I'm going to do this last one. So this is for matching, and because this is on your homework. So Annette makes $96,000 per year. Her company offers a 401k, and they will match 45% of her contributions up to 9% of her salary, meaning they're not going to contribute beyond what 9% of your salary is. The company will only allow employees to make contributions to a maximum of 25% of their salary. For the year in question, the maximum allowable is $22,000. So what is the most that they will allow her to contribute? $22,000, because it says right here that's the max. What is the maximum contribution she could make? Well, she could make 25% of her salary. So what's 25% of $96,000? That would be $24,000. So that's what she could make if they didn't limit it. What is her employer's maximum contribution amount? Well, if she can contribute $22,000, they're only going to match 45% of that, so 0.45. So 22,000 times 0.45, they will contribute 9,900. But that's a good, that's 9,900. She doesn't have to. Now, pause. It says it won't contribute past 9% of her salary. So we have to make sure that 9,900 doesn't exceed 9% of her salary. So 96,000 times 9% is 8,640. So that's the actual amount that they will contribute because they're not going to go over that amount. And that completes your notes.